Hello students, I am Dr. S.M. Bhatti. The objective of this video is to study correlation between the two variables. If the change in one variable affects a change in other variable, then variables are said to be correlated and the relation between them is called as correlation. If two variables deviates in same direction, that is, if the increase in one result in corresponding increase in other, correlation is said to be direct or positive. If decrease in one result in corresponding decrease in the other, then the correlation is said to be direct or positive. For example, correlation between income and expenditure is a positive. If the two variables in opposite direction, that is, if increase in one result in the corresponding decrease in other, or if decrease in one results in corresponding increase in the other, then correlation is said to be inverse or negative. For example, correlation between price and demand is negative. The correlation between volume and the pressure of a fluid is negative. If deviation in one variable is followed by the corresponding proportional deviation in other, is said to be a perfect correlation. As income increases, expenditure also increases. Income decreases, expenditure also decreases. Hence, the correlation between them is positive. While if price increases, then demand decreases. If price decreases, then demand increases. So relation is negative. Okay, so it is understood that the relation is positive or negative. But how to measure this relationship? And this is possible by Pearson coefficient of correlation. Let's see now formulas of the Pearson coefficient of correlation. Pearson coefficient of correlation. Correlation coefficient between two variables x and y, usually denoted by r in the bracket x comma y, or r lower suffix xy, or simply by r, and is a number measure of relationship between them and is defined as COV x comma y upon sigma x sigma y. So here r lower suffices xy, that means Pearson coefficient of correlation between x and y. Simply it is also denoted by r, or r in the round bracket x comma y. Now COV x comma y stand for covariance between x and y. Sigma x stand for standard deviation of x. Sigma y stands for standard deviation of y. Let's see now the formulas of COV x comma y. I said you just now, COV x comma y actually stands for covariance between x and y, and it has a value 1 upon n summation x into y minus x bar into y bar. Here x bar and y bar are arithmetic mean of x and y respectively. Sigma x is a standard deviation of x, and it has a value under root of 1 upon n summation x square minus x bar whole square. Sigma y stand for standard deviation of y, and we have a formula sigma y is equal to under root of 1 upon n summation y square minus y bar whole square. As I said you, x bar and y bar are arithmetic mean of x and y. That means we have a formula x bar is equal to 1 upon n summation x and y bar is equal to 1 upon n summation y. Here n stands for number of values or number of entries. Now if we want to find the value of Pearson coefficient of correlation, that is value of r, we must obtain three values if the situation is possible here. Find the COV of x comma y, find sigma x and sigma y. So you can obtain them separately. This is a formula for COV x comma y, this is a formula of sigma x, this is a formula of sigma y. So obtain these three values and put them here. And again we must note that the value of this r is always between minus 1 and plus 1. This r, that is a coefficient of correlation, is a number, is a real number which has a value minus 1, between the minus 1 and plus 1. If r is a 1, then perfect positive. If r is a minus 1, then perfectly negative. If r is say 0.8, then good. If r is a 0.9, then excellent. If r is a 0.4, then good. If r is 0, then one can say that no relationship between x and y. And if r is say minus 0.6, then it is a bad. If r is a minus 8.9, then it is worse. So like this, by value of r, we can understand the relationship between x and y. Now we have some other formulas also. So this is another formula, rxy is also can be written as summation of xi minus x bar into yi minus y bar upon under root of summation of xi minus x bar into summation of yi minus y bar. Or it can also be written as summation of xy upon under root of summation x square summation y square. Here capital X is x minus deviation from x bar, that is capital X stand for xi minus x bar, and capital Y stand for deviation from y bar, that is yi minus y bar. Now we must know some other results also which are useful in example. Suppose frequency is not given. Frequency is not given, and let's see now result when frequency is given. So here put u equal to x minus a and v equal to y minus b. If needed, if the numbers are more, then we can by taking suitable a and b, we can take u as a x minus a and v as a y minus b, so that u bar became 1 upon n summation u, that is u bar stand for arithmetic mean of u, and v bar stand for arithmetic mean of v, that is v bar equal to 1 upon n summation v. Now here n stand for number of values or number of entries, and here sigma u whole square became 1 upon n summation u square minus u bar whole square. Similarly, sigma v whole square became 1 upon n summation v square minus v bar whole square. And hence COV of u comma v can be written as 1 upon n summation uv minus u bar into v bar. Now everything is converted or in terms of u and v. Now we can write the formula of coefficient of correlation in terms of u and v also. So we can use the formula if it is required. R is equal to COV of u comma v upon sigma u into sigma v. So these formulas are when the frequency is not given. If the frequency is given, then as you know, sum of the frequency, that is a total frequency, is a capital N that is summation f, and in this case we put u is equal to x minus a and v is equal to y minus b, so that u bar became 1 upon n summation fu and v bar became 1 upon n summation fv. Then we have formula for sigma u whole square as 1 upon n summation fu square minus u bar whole square. Likewise, we can write down formula for sigma v whole square. Sigma v whole square is equal to 1 upon n summation f v square minus v bar square. Then COV of u comma v, that is covariance between u and v, is equal to 1 upon n summation fuv minus u bar into v bar. And formula for r remains same, that is r is equal to COV of u comma v upon sigma u into sigma v. These are the two references we have used while making this video. In this video, you have seen how to find a coefficient of correlation between two variables x and y. Actually, you have seen different formulas for finding the coefficient of correlation between x and y. In next video, we will see the problem where we will find the coefficient of correlation. Thank you very much for watching this video till the end.